For over 100 years, car companies were fighting one impossible problem: fuel waste. Not speed, not power. Every engineer was taught that a perfect engine could never exist because most fuel energy disappears as heat, noise, and friction before it ever reaches the road. Even the world's best cars waste most of their energy. One Toyota engineer, Hiroshi Tanaka, spent 23 years trying to break that limit. Thousands of prototypes, endless failures. In 2021, he admitted that going beyond 44% efficiency was almost impossible because of the laws of physics. He retired in 2025, believing the wall could never be broken. Then, 1 year later, China's Geely shocked the auto industry with a number: 48.41%. It was not a concept, not a lab test, a real engine. Instead of moving air normally, the engine creates a controlled tornado inside the cylinders, burning fuel more completely. It also uses a smart, integrated system that adjusts heat and timing every second for maximum efficiency. Experts said it should not work, but it did. If you love real engineering breakthroughs, impossible machines, and the technology changing our future, subscribe to Mr. Gear Engineer. Before we talk about how crazy 48.41% really is, you need to understand what that number means. When fuel burns inside a car engine, most of the energy never reaches the wheels. A huge part of it is wasted as heat, friction, and exhaust gases. In most normal cars, nearly 70% of the fuel's energy disappears before the car even moves forward. Think about that. You pay for 100% of the fuel, but only around 30% actually drives the car. And car companies have been fighting this problem for decades. Toyota, BMW, Volkswagen, all of them built incredibly advanced engines trying to reduce that waste. But even the best engines in the world usually stay somewhere around 40% efficiency, which means they still waste more energy than they actually use. And that is where engineers believed the limit was. Not because they ran out of ideas, but because physics itself started pushing back. The closer they got to perfect efficiency, the harder it became to improve anything. For years, the auto industry believed 40% was basically the wall no engine could cross, until Geely showed 48.41%. And suddenly, that impossible wall no longer looked impossible. What if I told you engineers didn't fail to pass 40% efficiency because they weren't skilled, but because they slowly stopped pushing in that direction? Over time, the industry stopped seeing it as a normal problem. It became a wall, a limit they believed was built into physics. This comes from something called the Carnot limit. Don't worry about the name. The idea is simple. Any engine burns fuel to create heat, then tries to turn that heat into motion. But physics only allows a certain amount of that heat to become useful power. That limit depends on one thing: how hot the engine gets compared to how cold the exhaust is. Bigger difference, higher efficiency. But in real life, you can't push that gap too far. Too hot, and the engine breaks. Too much cooling, and performance drops. So engineers are always stuck balancing between damage and efficiency. For decades, progress continued, but slowly. Each improvement became harder and more expensive. Then, Toyota reached around 41% efficiency, and that changed everything. It wasn't just another upgrade anymore. It felt like a final ceiling. Quietly, the industry started believing this is probably the maximum combustion engines can reach. Not because ideas stopped, but because the cost of progress became too high for very small gains. Many companies shifted focus to electric vehicles, and slowly, 41% became an accepted limit. Not written anywhere, but accepted in thinking. A wall everyone believed in, without ever saying it out loud, until someone decided to test if that wall was real. What if the limit engineers believed in was never really a limit at all? Because the first real crack in that wall did not come from Japan, Germany, or America. It came from China, and more specifically from BYD. At first, it looked like just another hybrid car company. Nothing revolutionary. But the thinking behind their system was completely different. In normal cars, the engine constantly reacts to the road. You speed up, it changes RPM. You slow down, it adjusts again. Every change pushes the engine away from its most efficient operating point. And that is where a huge amount of fuel gets wasted. So BYD asked a dangerous question. What if the engine did not have to react to the road at all? Instead of directly driving the wheels most of the time, the engine works more like a power generator. It stays in one highly efficient RPM range almost constantly. No unstable operation, no endless shifting, no wasted movement. The wheels are powered electrically, while the engine quietly stays in its most efficient state. Simple idea, massive impact. Because once the engine stops constantly adapting, fuel waste drops dramatically. And that is how BYD pushed efficiency close to 46%. Not a small improvement. A huge jump past what the industry believed was possible. For the first time, engineers were not looking at slow progress anymore. They were looking at a system that completely ignored the old rules. And suddenly, the impossible wall started to crack. What if the real problem inside car engines was never power, but how badly fuel actually burns? Because for over 100 years, engines have had the same hidden problem. Fuel inside the cylinder does not burn evenly. In a normal engine, air and fuel mix under chaotic conditions. Some areas become rich with fuel, while others stay weak. So when ignition happens, the flame spreads unevenly. Some fuel burns instantly, some burns too late, and during that delay, energy escapes as heat instead of pushing the piston. That means even powerful explosions waste a huge amount of energy. So engineers behind this new engine changed one important thing: the airflow. Instead of letting air enter the cylinder randomly, they force it to spin at high speed before ignition happens. Inside the cylinder, the air forms a controlled vortex, almost like a mini tornado, and that changes combustion completely. Now, the flame spreads evenly through a fast-moving spinning mixture. The burn becomes quicker, cleaner, and far more complete. Less heat gets wasted. More energy pushes the piston, which means the engine creates more usable power from the exact same fuel. And that is the real breakthrough. They did not just make the explosion stronger, they made the explosion smarter. What if I told you one of the biggest breakthroughs in this engine came from breaking one of the oldest rules in engineering? For decades, engineers believed an engine should stay at one stable temperature. Too hot causes damage. Too cold reduces efficiency. But this new system does the opposite. Instead of keeping the entire engine at the same temperature, it splits the engine into two different heat zones. The top part of the engine, where fuel burns, is kept cooler on purpose. Why? Because too much heat can ignite fuel too early, causing instability and wasted energy. Keeping this area cooler allows the fuel mixture to stay stable longer and compress harder before ignition. And higher compression means more power from the same fuel. But the lower part of the engine works differently. It is kept hotter on purpose. That sounds wrong at first, but there is a reason. Warmer oil becomes thinner, which reduces friction between moving engine parts. That allows the pistons to move more smoothly and waste less energy. So the engine uses two opposite temperature strategies at the same time. Cool on top for better combustion, hot on the bottom for lower friction. And a smart thermal system constantly controls both in real time. Without that control, the engine would fail. But somehow it works. What if one of the biggest reasons cars lose efficiency has nothing to do with the engine itself, but the gearbox sitting between the engine and the wheels? For over 100 years, cars have relied on transmissions filled with gears, clutches, hydraulic systems, and moving metal parts. And every one of those parts wastes energy. Every gear shift creates friction. Every moving component adds resistance. So even before power reaches the wheels, part of it is already gone. And those small losses happen every second the car is moving. So instead of improving the traditional gearbox again and again, this new system takes a completely different approach. It removes most of the gearbox entirely. Instead of sending power mechanically through multiple gears, the engine mainly works like a generator, running at its most efficient point. That energy is then sent electrically to the wheels. This is where the 11-in-1 integrated drive system comes in. The motor, controller, cooling system, and power electronics are combined into one compact unit instead of separate heavy components. Fewer moving parts, less friction, less weight, less wasted energy. And that changes everything. Because now the car is no longer focused on mechanically transferring power step by step. It is focused on managing energy in the smartest way possible before it even reaches the road. And once you see that, the traditional gearbox starts feeling less like advanced engineering and more like old technology we simply got used to.
At this point, everything comes down to one question. Did all this engineering actually change anything? Or is it just complex design with no real impact? Because now we reach the number that started the story, 48.41%. This is the claimed peak efficiency, measured in real testing conditions that pushed it into serious industry discussion. To understand how big this is, compare it to normal cars. Most engines today still waste a large part of fuel as heat and friction. Even advanced cars from top companies stay far below this in real driving. But here, fuel consumption drops to around 2.2 liters per 100 kilometers, and that changes everything. Suddenly, driving range is not what we are used to. In ideal conditions, it can reach close to 2,000 kilometers on a single tank.
That is not a small improvement. It's a completely new level for fuel-powered cars. And this is where things get serious. These numbers don't stay in laps. They get tested, compared, and debated worldwide, because when results like this appear, everyone wants to verify them. But the real impact is not just the number. It is the comparison. Against normal cars, the difference is now clear in fuel use, range, and efficiency. And that is what makes this moment powerful. It doesn't just improve old technology. It changes what people believe is possible. At this point, this is no longer just an engine breakthrough, because once efficiency reaches numbers like this, the conversation changes completely. For years, the future of cars seemed simple. Electric vehicles would replace combustion engines. Electric cars are clean, quiet, and highly efficient. Gas engines were seen as old technology. And hybrids? Most people thought they were just a temporary step before full EVs took over. But breakthroughs like this change that idea. Because when a hybrid system delivers extreme efficiency, long range, and fast refueling at the same time, it stops feeling like a compromise. It starts looking like a real alternative. And one big reason is infrastructure. Electric cars depend heavily on charging stations and strong power grids. But in many parts of the world,
fuel stations are still far easier to find than fast chargers. That changes how people actually use technology in real life. This is why high-efficiency hybrids are becoming so important. They work with the fuel system the world already has, while using far less fuel and giving much longer range. And now, automakers are under pressure from both sides. They are investing billions into electric vehicles, while also seeing combustion technology suddenly improve faster than expected. And another thing is changing too. For decades, Japan, Europe, and America led the car industry. Now, China is moving forward extremely fast. And that is creating a completely new global race. Because once one company breaks the limit, everyone else is forced to catch up.
Now, this is where the real question begins. Do you think the future still belongs fully to electric cars? Or could high-efficiency hybrids stay important much longer than people expected? Because right now, the industry is changing fast, and breakthroughs like this are making the future a lot less predictable. So I want your opinion. What wins in the long run? Full EVs or smarter hybrid systems pushing combustion technology even further? Comment below. I read all of them. And if you enjoyed learning about real engineering breakthroughs in a simple way, subscribe to Mr. Gear Engineer, because the next breakthrough might completely change the car industry again.